All right. Hello, everyone, and welcome to the stream. I hope everybody's doing okay tonight. Hey, Weird Trash Can, how's it going? Welcome. So, before we kick off, just a couple of things to take note of. I want to take a quick second to thank all of the supporters of the channel, starting with our partners, which are the highest tier of support over on Patreon and YouTube. They are Arslia, Garbolis Inc., and Patrick Coleman. I would also like to thank everybody else listed under the supporters section. They are the other tiers on Patreon as well as YouTube, in addition to Twitch subs. Thank you guys very much for your support. I greatly appreciate it. I would also like to extend a welcome to any of you who are viewing this either live or on YouTube as an archive. Without you guys, of course, none of this would be possible. So thank you guys very much for following along and interacting. With all that said, tonight we are going to be picking up where we left off last night. So we are going to be continuing the implementation of our render graph. So that is kind of what is on the roster for tonight. I'm good, Trash Can. How about you? Glad to have you here. So as you guys have probably seen on screen a couple of times, we are going to be implementing this guy here. And so this is the drawing that I sort of had up last night. So I actually didn't throw it away. I kept it just in case we need to update it with anything. So yeah, with all that said, let's go ahead and jump into the code. Let's see. You have no uni tomorrow, so you can watch the stream more than yesterday. Awesome. Cool beans. I'm actually technically off work tomorrow, but I don't know if I'm going to stream later or not tonight, just because I had kind of a long day with work, and I'm a little bit brain dead. So we'll see where we wind up. All right. So let me just refresh my memory here. So I think we have. Do we not have the Rendergraph C file? I don't think we do. I don't think we created that yet. Okay. So I think we have everything on the header file that we need. We've defined our interface, so we can actually start on the implementation of this stuff so that we can actually take a look at how all these pieces are going to come together. So my plan for this is that we're going to build out the render graph itself first, and then we're going to go through and build out the individual passes. So the passes we can kind of think as a replacement for what we have in the testbed lib views. So these guys right here, we're going to be kind of splitting these into individual sort of render passes, right? And I know the drawing that I had here did not actually include the wireframe pass, but we're going to try and tackle that as well, probably last. And then I also do want to take a stab at the pick pass and get that implemented here. And that's actually going to be split up into two passes. So I'm thinking all of that stuff is probably going to wind up around here somewhere, I'm guessing. So let's go ahead and start off by, we'll open, it's going to be engine, source, renderer, rendergraph.c. And of course we are going to include rendergraph.h. Did I put include guards on this? I don't remember. Yes, I did. Okay. So I guess what we'll do is I'm just going to grab all of these guys and go back to the C file and drop them in. And we're going to get rid of all the K APIs. Nivlak, how's it going? Why does the mods have to watch ads? I don't know if I can control that, actually. You managed to implement the D-array header struct I created yesterday. Feels good. Awesome. Sweet. Am I quiet? Is my volume kind of quiet? It looks like it's decent levels on the mixer. Bump up the gain a little bit, I suppose. Yes, you mentioned that you were rebranding. Yeah, I do know who you are, by the way. Obviously, because you're the only one with mod privileges. But yes, I did know you were rebranding. And I do like the new brand, by the way. Okay. So... I'm just going to do this real quick. There's probably a faster way that I can do this. I just don't know what it is. I suppose I could do a find and replace, right? But by the time I type all that out, I'm basically done with this anyways, so... Right. Okay. So, I guess probably the best way to do this is going to be to work top-down, right? Because that's kind of the way that that I've structured these functions anyways, or ordered them, is sort of in a top-down fashion. So I think that's probably going to make the most sense to go ahead and do. So a couple things that I know we're going to need right off the bat. We're going to need the core logger. We are going to need application types because of this application right here. So, oops, include, what was that under? I think it was application types, right? We're going to need to allocate some memory, so we're going to need core K memory. We're going to need to do some string processing for all these strings that we're taking in for these functions. So we definitely need K-string. Let's see, what else? We're going to need access to the renderer front end. Renderer front end. I'm going to go ahead and include renderer types too. Renderer types. I'm also going to include frame data. Just because I suspect we're going to need that as well. Because we are passing it in a couple places here. Let's see. Now I'm at 60%. That's really strange because my levels in OBS look okay. I can try. Let me see. I pretty much have everything maxed out, so let me see if there's another way, because I don't really want to like pump up the gain so much that it kind of starts distorting things. How about that? I mean, that's about as hot as I can go, I think, without it clipping, and it might even clip. I'm not sure. Hydrate. Thank you for that. Appreciate it. No, I know you're not some random person with mod powers. It goes with it goes by the account. So even if you change your name, it follows you. There we go. 45%. Do you mean like volume 45%? Because like I don't know if you can tell, but like the microphone's like literally, I don't know, maybe 3 inches from my face. Okay, so you guys can hear me okay though, right? Okay. If it's only off by like 5%, I'm not gonna I'm not gonna worry about that too much then. All right, so the first thing that we're gonna want to do is we're gonna want to obviously do our create, and we're gonna need to start off with some sanity checks out graph, right? So obviously if we don't have that, we can't do anything. So we're gonna return false there. And then we're just going to do a few simple things for as far as initializing the render graph for now. There may be more to this in the future, but for right now, I think this should be sufficient. We're basically just going to fill out the struct. So we want to say out graph. We'll start with the name, and we'll do a string duplicate on that of name. Let's see, the app pointer is obviously just going to be app. Let's see. So passes is going to be a D-array of Rendergraph pass pointers. So we'll do a, I don't think we included D-array in here. We did not. Include containers D-array. So this is going to be D-array create. Whoops. D-array create. And the type of that is going to be Rendergraph pass pointers, right? Because it's a array of pointers. And then we want to do global sources, which we can have many of those. We'll do a D-array create of Rendergraph sources, right? And those don't need to be pointers to anything. So that should just be a flat array. Okay. I think that is basically all we need to do to stand up what we need for the render graph, at least at the create phase. So obviously we'll have to go ahead and pre-fill out the destroy. So we'll say if graph. And then I guess for the sake of completeness, we'll check each one of these if they exist. So if graph.name exists, then we'll do a, do we have a string free? Yeah, we do. So graph name, graph name equals 0. This is just me kind of being pedantic about it, but discards qualifiers. Oh, right, because it's const, isn't it? I'm guessing. Yep. Doesn't need to be. All right, it's only really for debug purposes only anyway. So say if graph passes, D-array destroy, graph passes. Anywho, lurkin' time. Thank you for the lurk. I appreciate it. It's clear compared to the background music. Okay, that's good. It's a little hard for me to tell sometimes. So I'm still trying to strike a balance there. But yeah, thank you guys for letting me know. Graph passes. And then this is basically going to be the same thing for global sources. All right. And that should be good for now. I guess we can just go ahead and just set graph app to 0, right? Because this doesn't own that, so we don't have to dispose of anything. That'll handle the destroy for right now. We are eventually going to have to free some resources, but we can worry about that later. Okay. Meborn, thank you so much for resubscribing. 3 months. Thank you so much. I appreciate that. And welcome. All right, so now we're going to start off with the addition of a global source, which is very good. It's going to be very similar to adding a a source to a pass, except we're not going to be adding it to a pass. We're just going to be adding it as if the global frame itself is a pass, right? So we'll say graph. If I guess we'll do the negative check here, right? If not graph, return false. Otherwise, return true. So for this, all we're really going to do is fill out a source structure internally and just push it to our array. So we want a Rendergraph source, and we'll just call that source. And we'll set it, we'll just zero it out, right? We'll say source name, and of course that's going to be a string duplicate right there. And we're going to take in name for that. Source type equals type, right? Source origin equals origin. Source ID. Source ID. Excuse me. I'm not 100% sure that we're actually going to use the ID. You know what? I'm going to get rid of... I'm going to get rid of the ID. I'm going to get rid of it on the syncs as well as on the passes, because we have names, right? I don't think we need IDs. Maybe for lookups later on, if we want to, we can sort of add those back. But I think for now, I'm just gonna omit those, right? We'll simplify this a little bit. So I guess source. Let's see. The only other thing is going to be textures, right? Which we actually can't fill that out yet. We'll fill this out during the linking phase, I'm thinking. Yeah, we'll fill that out during the linking phase. I'm not going to do that now. All right, so all we're going to do for now is D-Ray push onto graph global sources source. All right. And then we return true, and that is adding a source, right? So it's basically going to wind up being very similar to this method down here. All right. Before we do that, though, we should probably go ahead and step through the creation method for a render pass, or render graph pass, rather. So obviously, if we don't have the graph, or we don't have the out pass, we're going to return false, right? Let's see. Not related to the engine, but you think it's hard for someone that are only used to Windows, KDE, XFCE to learn something like i3. So, no, I don't think it's hard. I actually, if you look at some of my previous streams, I was using Hyperland for a while. And I really, really liked it. The only reason I actually switched away from it is because I got tired of things not working under Wayland correctly. Things being full screening videos in Chrome basically brought the whole thing down. And then I also had another issue where Blender wouldn't work with the DPI scaling under Wayland for some reason. Because I actually have different DPIs for some of my monitors. So 2 of my monitors are 4K, 2 of them are just 1080p. And Wayland does really well at managing that, but for some reason the high DPI monitors just don't run Blender correctly under that, and I don't know why. Yeah, I didn't even try Brave, but yeah, I had lots of weird issues with Wayland, so I actually had to sort of leave it behind. Which sucked because I actually really, really liked that environment. I'm using Cinnamon now, just because Cinnamon has pretty good support for different high DPI and regular, HD displays mixed. I can't speak for whether i3 supports that or not. But yeah, I don't think it's going to be difficult to get used to at all. It's just a different paradigm, just like anything else, right? Hope you don't break Arch. No, I don't think you will. I have like 5 different windowing systems installed on this instance of Arch, right? So I don't think you'll break it. Let's see. So funny story, while your sound was quiet before, my volume for the computer in general, not my speakers, was actually lower. Really? So is my sound like too hot now? Because it's like right up, it's pushing right up against peak. I think I'm going to back it off a little bit. Just because I really don't want my audio to be peaking. Right about there, I think is good, probably. Yeah, I think that's what I'm going to stick with. Okay. All right. So to create a render pass, again, it's going to be kind of filling out a structure, but we also have some stuff to kind of set up, right? So before we do anything else on this, the first thing that we need to do is make sure that there, it isn't already another pass with this name, right? So since we're naming them, we need to make sure they're unique. So u32i 0i is less than, you know what, I don't want to call the D array count all the time, so let's do a u32 pass count equals D array length, and that's going to be graph passes. And then here I can say pass counts, and then plus I, right? And then, so I should put this into context. So all of this stuff that we're doing here, so the source adding, the pass creation, the sync adding, setting the linkage, all of that stuff, all the way up to finalize is all happening during the startup phase of the engine, right? So we're not actually going to be running this stuff every frame, right? This is not going to be part of the real-time code. So we're going to be doing lots of like string comparisons and things like that in here that aren't necessarily fast, but I'm not super concerned about it because it's not something we're going to be running in a tight loop, right? So for right now, we're just going to start off with just a naive string comparison. And if we need something with a little bit better performance than looping through a linear array, like when we have a really complicated render graph, maybe at that point we can set up a hash table or something, which we do have. I'm not gonna set that up right now. So we're basically gonna do strings equal, and I'm not gonna do the case insensitive version of that. I'm gonna keep this case sensitive, and we're gonna look at graph passes sub I dot name, and we're gonna compare that to the name that's passed in. Right, and if those things equal, then we're going to do a k error, and we're going to say unable to add pass because a pass named string already exists. And we'll just pass name there, and we'll return false, right? So we're going to do that as a sanity check first and foremost before we allocate anything, right? Next thing we'll do is we'll go ahead and fill out things like the name, right? So that's going to be another string duplicate name. And then we'll go ahead and do outpass sources equals darray create render pass render graph source, and outpass syncs is going to be darray create render graph sync. Right, so we want an array of those. Which I think that's all we need to create on the pass for right now. The next thing that we're going to do is we're calling, or we're passing in a create function pointer. And this is what's going to set up the pass specific stuff itself, right? So what we call render pass create, that is in turn going to invoke a create function that we pass here. So that returns a Boolean, as we see here, which actually this syntax is wrong. That should be that. So we'll say if not create PFN, and we're going to pass it out pass, since that's the pass that we're creating. So if that fails, then we'll say k-error, and we're going to say error creating render graph pass, see logs for details. And what we're expecting here is that the pass itself will actually output some messages having to do with that stuff, right? And the reasons that it failed. And then last but not least, we'll do darray push. K6L2, thank you so much for the follow. I appreciate that. And welcome. And we're going to push this to graph passes, right? And that's going to be out pass, right? And then of course that also gets written out so that the application can own that, right? So that is creating our pass, right? All it basically does is just kind of stand up our arrays for us and some basic information about it, does some quick checking, and gets it ready to be linked against with sources and sinks. Let's see. You listen to a lot of loud streamers, so your hearing's a bit questionable. Yeah, I try to avoid loud streamers actually. Like, I turn a lot of those off. I'm not a huge fan. On OBS, I found a good level. At least no one's complained to me. When the loudest you want to be is barely touching the yellow zone. Yeah, I mean, for me, it's like, ideally, you want to be as hot into that yellow zone as you can be without actually ever clipping into the red. Because that's how you're going to get the best quality sound without actually clipping. You'll get the clearest quality that way. So that's usually what I aim for. All right. This correction here, I actually wonder if I need to make that in the header file. Let's see. Let me move this from behind my head so that you guys can see it. So that was not there. And it should be. Cool. All right. So that is that. So now the next thing we need to do is add a source. So the source is a little bit more code, but again, it's not going to be anything terribly complicated, right? So the first thing that we have to do, obviously, is we want to check to make sure that we actually are passing a valid pointer to a graph. So obviously, if not graph, we're going to boot out. Return false, right? And along the way, we'll probably add a little bit more advanced error checking to this as we see stupid stuff we run into along the way. But for now, I'm going to keep it simple. So when we go to add a pass source, right, or a source to a pass, you'll note that we're not dealing with pointers to passes here, right? We're not, we don't actually have access or external access to the sinks or the sources. And that's really by design because we should not be modifying those things outside the context of a render graph. Let's see. I think we're about to hit an ad break, so I will finish that explanation here in a second. Got about 50 seconds left on ads. About 25 seconds. Then we can get back into it. All right, and we are back. So, for those of you who are new to the channel, I like to break the stream whenever ads come up so that you guys don't miss any content. Because I know at least when I'm watching a programming stream, nothing is more annoying than not being able to hear what the person is saying as they're writing some code, right? So I try to avoid that. Sometimes I do miss the ad breaks. I don't necessarily happen to see that it goes off, but most of the time I'm getting pretty good at seeing it. All right. As I was saying before, we don't manage pointers to sources or sinks outside the render graph. That is by design. We have no reason to ever do so. And so what we do instead is we basically deal with names of those things. And so when we add a source, we add that source by name, and we add that to a pass by name. And basically the way that we do that is we search through the render graph for a pass with that name, and then we add a source with that name to that pass using the information that's passed through. So what that basically means is that we need to find the pass first. And this is what I was saying. We're not doing this during runtime. We're not doing this during like our update loop or any of that stuff. We purely do this before as we're sort of standing up the application. So we are doing lots of string comparisons in here, but it's not really a huge deal, right? So we'll say, you know what? Actually, I think we had a pass count here. So I'm actually just going to copy pasta this, and we'll be able to reuse it. So we have strings equal, and this is going to be pass name. And this time, if we have a string equal, we actually do want to process this, right? So in this case, what we're going to do is we're going to say, we're going to come up here actually above the loop and say Rendergraph pass. And that's going to be a pointer, and we're just going to say pass, right? And we're going to start that off equal to null. If we find one that matches, we're going to say pass equals graph passes sub I, and then we're going to break. Okay. And then down here, Blitzkrieg 009. Thank you so much for the follow. I appreciate that. And welcome. So here we're going to make sure that we actually found a pass, right? So the pass should not be a null pointer by the time we get here. If it is, then the configuration of the render graph is invalid. So unable to find a render graph pass named string. And we'll do pass name there. And return false, right? So now that we have the pass, we can go ahead and double check that pass to make sure that it doesn't already have a source with that name, right? Because we can have one sink and one source with the same name, but we can't have two sinks or two sources with the same name. So verify that the pass doesn't already have a source of the same name. So we're basically going to wind up passing, or we're going to be reusing this loop So I'm just going to put that in here. And I'm going to call this source count. And this is going to be pass sources, right? This is going to be source count. And then we're going to want pass sources sub I name, right? And then we're going to compare that against the source name. And if we do have a match, we're going to k-error, and we're going to say the pass string already has a source named another string, source not added. And so for the two strings, we're going to have pass name, and source name, right? And then, of course, that's invalid, so we're going to return false. Okay? So once we've verified that all is good, it's at this point that we can actually go ahead and create the source and push it. So we can say Rendergraph source. We'll just call this source. We will zero this out to be safe. And then we'll say source.name equals string duplicates. And we want source name. Source.type equals type. Source.origin equals origin. And then darray push pass sources source. Right? So that is all there is to creating a source, right? There's nothing too complex on here. It's just basically verifying that how we're trying to configure this is correct. And we'll do some additional verification afterwards. All right, so the next piece of this is basically adding a sync, which actually follows almost exactly the same steps. So I'm actually going to copy this up until the source part, right? Because it's 90% the same. So we have to find a pass. That changes. We verify that. We verify the pass doesn't already have a sync of the same name, right? So this is going to be sync count. This is going to be pass syncs. This is going to be pass syncs. This is going to take in sync name, right? Already has a sync named that. Sync not added. Sync name, right? And then we go ahead and create that. Let's see. So all we'll have to do now is just sort of like before, we'll just fill out a sync, which actually the structure for this is really, really simple, right? So we'll have Rendergraph sync. We'll start off with a zeroed out structure, and then we'll say sync dot name equals string duplicates sync name. And we're just going to push that, right? Because it really doesn't hold much more than a name, other than a pointer to a source, which we're going to create during linking. So darray push pass.syncs, and we'll push the sync. And then return true. And that is all there is to adding a sync, right? That's pretty straightforward stuff, I feel like. All right, the next thing that we're going to have to do is a little bit more complicated. We are actually going to be reusing some of this same logic again. So what I'm actually going to do is copy this first part. So setting the sync linkage. What this is going to do is it takes a pass name and a sync name, and then a source pass name and a source name. And what we're basically saying is take this source from this pass and hook it up to this sync and this pass, right? And that's how we go ahead and link and make that connection. And so this is going to use that data to basically iterate through everything we have and find and match those things if they exist, or bleat about it and fail if they don't. So the first thing that we have to do is we have to find the, we're going to call this the target pass, right? And that's going to be the same as we've already done before, so I'm not going to worry about that. Unable to find Rendergraph. I am going to call that target pass. And then the next thing that we're going to need to do is find the target sync, right? So that is actually going to be basically this loop, right? Except instead of a failure, we're going to have a pass, right? So we're going to loop through the syncs on that pass, right? And if we find it, then we're going to go ahead and set a sync pointer to it. So I will say Rendergraph sync, sync, right? That's a sync pointer. We'll start off zeroing that out, and then we'll do sync equals the address of pass syncs sub I, right? And we'll break. And then similar to how we did up here for the pass, we'll do down here for the sync. So we're just going to change this to sync. Unable to find a Rendergraph. Let's see. Let's do find sync named string on Rendergraph target pass named that, right? So we'll say sync name pass name. Okay, so that's the first half of it, right? So we get the target pass and the target sync, and make sure that we have those things. And then we basically just need to repeat the process for the source and the source pass name. However, there's a kind of a big but here. So we have two basically sources, or I should say origins of sources, right? We have that global context, which actually, let me switch back to this guy. Right, so we have the global context, which is these guys, right? So these are our global sources, right? And then we have the individual, sources on the passes themselves, right? So that would be this one, this one, this one, this one, this one, right? And this one, right? So basically the difference between these two is if we are talking global, meaning like something like these guys here, ones that have been added globally, we would pass 0 for the source pass name. And that's basically saying this doesn't belong to a pass, it's global. Otherwise, if it does belong to a pass, then we go ahead and evaluate this. So a null value for source pass name is valid. It just means global in this case. So we'll actually wind up taking a look at that first to determine kind of what scope we're looking at. And then from there, go ahead and pick out the source by name. For I-24, thank you so much for the follow. I appreciate it. All right, so with that in mind, what we're going to do is Rendergraph source. We're going to create just a convenience pointer to that. We'll start off with a null pointer. And then we'll say if there is no source pass name, right, then we're dealing with a global source, right? Otherwise, we're dealing with a pass source, right? So that's the main difference there. So the next thing I'm going to do is I'm actually going to go ahead and grab another one of these loops up here. So we're going to take this one, just because I don't want to rewrite that loop again. And I'm actually going to paste it twice. And we'll get to the second version here in a second, right? So this global source here is basically going to loop through the global sources. So instead of pass sources, we're actually going to say graph, and then global sources, right? Then we have our source count, that's the same. This is going to be graph global sources. Whoops. Global sources, right? And the name that we're going to use is, I think, actually it is just source name, right? Yeah, it's just source name. So that's the same. And then, obviously, instead of a fail case here, we're going to just use we'll set source equals to the address of graph global sources sub I, right? Obviously, we'll need to break that as well, okay? So that's all we need to do for the global source. It's actually pretty straightforward stuff. For the non-global version of it, we actually have to search for a pass by this guy here. So we're actually going to have another one of these. Right, so I'm going to just copy this guy and put this, let's see, right here. Right, and we'll put a little space in here. Okay. And this is, we're actually going to rename this guy to source pass, right? And then pass count is going to be graph passes, just like we would do before. And then here we're going to be looking for graph passes name, but instead of pass name, we're going to say source pass name. If we find it, then we're going to set the source pass to that and break, right? And then if we run into a situation here where we don't have a source pass. So if we don't have that, obviously then we will error about that. Unable to find source pass named string. Right, and we'll do source pass name, and that's going to return false. Okay, so we have that, and then we actually need to find the source within that, right? So we have pass sources. Instead of looking at pass sources, we're going to look at source pass sources, right? This is going to be source pass sources. And then we don't need this line. What we need here is if we find that match, then we're going to set the source is going to be equal to the address of the source pass sources sub I, right? And obviously we need to break that. Okay, so at this point we should have definitely found a source, right? But we do need to double check down here at the end of all this stuff to make sure that we've actually found a source. So let's go ahead and verify that. So if not source, we'll say k-error, unable to find source named string, and then we'll say source name and return false. Okay, so if we get past this last and final check, then all we actually have to do is link it. So we have everything needed to perform the link is present. So do the thing. If I can type that. Right. So all we have to actually do is now say sync bound source equals source. Return true. Okay. So it seems like a lot of code, but realistically all we're doing is we're just looking through all of our passes and their sources and sinks, and we're just gathering up those things and just literally setting a pointer, and that's all there is to it, right? Okay, so let me check on chat here for a second. Crap, you're right. I did forget to change screens. My bad. You're totally right. Okay. Sorry about that. Okay, so I'll just kind of quickly step through this because I think you guys kind of probably get the point. Anyway, sorry about that. Noob mistake. I told you my brain was fried tonight, and I guess I wasn't kidding. All right, so basically at this point, what this is doing is we find a target pass, right? We make sure that we have that target pass. We find the target sink within that pass. We make sure that we have the sink. The next thing that we search for is the source. So if we have not provided a source name, then that means we are going to look for a global source, which is within that drawing. That is in the color or depth buffer, for example, right? So we search through those by name, and we assign the source pointer here if we have it. Otherwise, if we did provide a source pass name, we go ahead and we get the source pass. If we don't find that, we bleat about it. And then we loop through the sources of said pass. And if we find that, we set the pointer. Then we do a check down here to say, hey, do we have a source? Yes or no? And then if that passes, then literally all we have to do is set this pointer. So we set the sink that we found. We set the bound source to that source, right? It's literally just setting a pointer at the end. And that's all this does, right? For now, that's literally all there is to it. Okay? So that is the linkage. Thank you guys for pointing that out, by the way. I'm sorry I didn't look over at chat sooner. But yeah, I'll try and keep an eye on stuff like that going forward. All right. Incidentally, speaking of that, if you guys have any questions or anything along the way, I do try to keep an eye on chat. Sometimes it can be like 5-10 minutes before I see something, but feel free to ask any questions if you have them, right? This is designed to be an interactive stream. I enjoy talking with you guys and interacting with you, so feel free to hit me with questions if you have them. All right, so the next thing that we're going to take a look at is the finalize, and this is probably going to be probably the largest bit of code that we're going to have. Let me just check my notes here because I have sort of a list of things that I need to implement here. So I think we are actually missing a private method that we need to add first before we can do this. So let's go to the top, and let's get that added in. So I'm going to just forward declare that. So we're going to say that's a static B8, and we're going to call this regenerate render targets. And this is going to take a render graph, right? So we obviously always need that. And then we're going to take a, render graph pass. All right, and I'm going to take this and go down to the bottom. And put it here. Okay, so what do I mean by regenerate render targets? So if we look at our view system, which is sort of the thing that we're converting from to get to this render graph, we actually have a pretty much identically named function in here. And so we have these things called render targets, which a render target is basically has a number of attachments, and those attachments have a type, a source, a load operation, a store operation, present after flag, and a texture. So if you guys have been watching this for a while, you'll kind of know what that stuff means. But essentially what we're dealing with here is this is the underlying resource that we're going to be dealing with. So these textures right here is actually an array of textures. And that is either the, in this example anyways, it's either the color texture that we write to or the depth buffer texture that we write to. And then the load and store operations are what we do with that texture when we're done with the render pass. The source has to do with where that actually comes from. And then the type actually specifies, is this a color attachment type, or is this a depth buffer attachment type, depth stencil attachment type, right? And so this is basically a structure that holds all of that kind of information. And so one attachment basically can hold multiple textures because we can have multiple frames in flight. So at least on my machine here, we're actually using triple buffering because my hardware supports that. And so what that means is we're actually going to have for the color frame buffer, we're going to have 3 textures, and for the depth buffer, we're going to have 3 textures. And based on whatever the renderer frame number is the texture that we actually draw to at that given time. And so this is what brings all those pieces together. And so the render target attachments are attached to a render target. And then, so we might have an array here of 2 attachments on a pass that takes both the color and the depth buffers, right? Versus like on our skybox that only takes the color attachment, we would only have 1 in here, right? And then of course the internal frame buffer that's used by the graphics API, which is a VK frame buffer in the case of Vulkan, right? And so we don't have an external concept of a frame buffer. That's all internalized to the graphics API. But that is basically what that stuff is. So the render targets basically need to be set up. And in the view system, we were sort of just looping through all the render passes and creating those render targets. And the way that we were doing this is we actually set this up in a regenerate method, not a generate method, because generating them and regenerating them is the exact same set of steps. It's just whether or not you need to destroy existing ones first or not, right? And so the reason that we would need to regenerate render targets would be like on a window resize or a viewport resize. If we change those things, then obviously the size of what we're dealing with can actually change, right? And so that is basically what all of this is doing. And we're going to actually wind up using or reusing most of this logic to actually handle that. So it's not going to be a straight copy pasta. So what I'm actually going to do is we're going to rewrite this code, but we're going to rewrite it over in our render pass so that we have just sort of a review / better understanding of what exactly is happening. Okay. All right. So I think probably the first thing that we should do is start off with our sanity check, right? Like we always do. So if not graph or not pass, return false. And it looks like we have ads. So I will break for that. If I can type it. There we go. It's a few seconds late on the ads that time, but I did still catch it. So we got about 50 seconds left. About 15 seconds. All right, and we're back. So just for those of you who are new to this, I'd like to break the stream whenever we have ads, just so that you guys aren't missing content when the ads are up. Or, you know, if I forget to change screens. Okay, so for our regenerate render targets, I'm going to go ahead and just stub out the return true for the success here. So obviously, if we've passed this check, then we need to go through and handle each one of these passes, right? Now, we're not going to be doing all the passes in one sort of loop like we did in the view system. We're going to handle this a pass at a time as it's passed here. But the Rendergraph pass itself, if you recall, has a render pass in it that we're going to go ahead and examine. So I'm going to say for u32i equals 0, I is less than pass, right? And that's the internal, that's the render pass, right? The actual, the structure that holds the render API data. And we're going to say render target count, right? And that's how we know how many render targets we need to actually generate, right? So we're going to loop through those. And we'll say render target pointer, we'll just call this target, is equal to the address of pass pass targets sub I, right? And we'll next need to check to see if this actual render target exists and already has resources, and destroy it if it does. So destroy the target, we'll say the old target, if it exists, right? And basically we just do that by render target destroy, and we'll pass target. And then for this free internal memory, we do not want to free the internal memory. And that's basically because we are going to reuse this render target structure, right? So we don't want to completely obliterate and have to reallocate memory within that. We want to just use what's already allocated for it. We're basically just going to re-stand up the resources within it. Okay, so the next thing we need to iterate is attachments. So we're going to say u32a equals 0. A is less than target attachment count plus a, right? And we'll say render target attachment pointer, attachment, we'll call it. That's going to be the address of target attachments sub A. Okay. And in this, we'll say if the attachment source is equal to render target attachment source default. What that basically means is that we are going to get the default render or the window attachment, right, which is ultimately one of the swap chain images, is what we're going to obtain there. So if that's true, we basically need to say, okay, well, which one do we need? Do we need the color or the depth, right? So if attachment dot type equals render target attachment type color. So if it's a color type attachment, we'll say attachment texture, which is just a pointer to a texture, is going to be render window attachment get, and then we're going to want an index for that, right? Which is simply just going to be I, right? So that's going to be the sub I that we're dealing with here, right? So that lines up with that. Otherwise, if the attachment type is render target attachment type depth, attachment texture equals render depth attachment get, and that's also going to be sub I, right? So we just want to get that. And then for some reason, if the attachment type is something else, we're going to bleat about it, right? Because that's definitely not correct. So we'll say unsupported, or unsupported attachment type. And we're going to do a little bit of fanciness here. We're going to get the hex of this. And so that's going to be attachment type, right? And that'll just make it a little bit more clear when we compare that against the enumeration, what's going on. So return false, right? So that is the source default. The other option that we potentially have is else if attachment source equals render target attachment source. And this is view, right? Which is actually something we're going to wind up deprecating. And so we're going to say kfatal self-owned attachments not yet supported, right? And return false. We're not going to support this yet because we actually need to remove this concept of a source view, right? Because technically views aren't going to exist after this. It's going to really be a source pass, right? Or self-owned, right? And in that case, what we're basically going to do is pass off the attachment getting. We're going to pass off the regeneration of that, rather, to a function of the actual pass itself, right? So I'm actually going to put a to-do here so I don't forget to do this. So we'll say self-owned attachments for Rendergraph passes, e.g. call a pointer function to regenerate attachments, right? And then it'll be up to the actual Rendergraph pass to know how to do that, right? An example of where we're going to do that is actually going to be the pick pass, right? When we go to set that up. So that's probably something we should stand up at some point just to verify that all this works correctly. Okay, so at this point, we can go ahead and assume that this is going to work because all we're going to deal with is that first case for now. And so down here, we actually are going to go ahead and create the render target. So we're going to call render target create. And this is going to take a crap ton of parameters, which, I don't know, maybe I'll convert this to a structure at some point. But for now, I'm going to say target attachment count is the first parameter. Then we want the attachments itself, so that's going to be target attachments. The render pass is going to be the address of pass, right? The width is going to be the target attachments, and we're going to take just the 0 attachment, right? Because we don't really need to, like the attachment indices are not going to be different sizes, right? They're all going to be the same size. So we'll say texture width, right? And then we'll do the same thing here for height. So target, attachments, 0, texture, height. And then the render target itself is just going to be the address of pass targets sub I. And we will have our created render target. LSR, good evening. Welcome. How are you tonight? Hope everything's going well. So let's go ahead and I'm just going to add a comment in here. I guess it's kind of not necessary, but create the underlying render target. Okay. So this is going to basically automate a lot of that work for us. We're not going to have to do this for each one of the render passes as we set them up, right? Or the render graph passes, rather. Because otherwise we'd have to have this code basically repeated in every single pass, and it's going to be the same, right? So why not just handle it here? In addition, this also knows how to deal with global versus locally owned. So that's why we're doing that there. I've been using i3 for years now, and I don't think I was very familiar with anything other than a desktop environment at that point. And I'd say it's fairly intuitive. Yeah, I've used i3 a little bit. I have more experience with Hyperland, which I really like, but it's also like cutting edge, bleeding edge new. But yeah, I might switch to i3. Do you happen to know how the support for mixed high DPI devices is for that, like displays? So for example, I've got 4K monitors and then regular 1080p HD monitors. That's a little bit of a tricky thing on Linux. So the only X environment that I've actually gotten to work well with that is Cinnamon. X doesn't really seem to like that too much. Yeah. I'll bet you were fighting that at one point. Yeah, if you ever have had multiple devices like that, then yeah, you probably will have definitely hit it at some point. All right, so the next thing that we need to do is we're going to fill out our finalize and our execute frame, and then our render graph should essentially be done. And then all it is just building out the individual render passes, which is neat. Let's see. If I remember correctly, I don't think I ended up finding a good solution. Yeah, I didn't really find one for a lot of desktop environments either. Seems to be, it's pretty gracefully handled by Wayland, but on X, not so much. All right, so obviously, if not graph, return false. And I'll go ahead and throw a return true down here. And you know what? I'm just going to copy pasta this here. All right. Okay, so finalize. What do we mean by finalize? So there's a couple steps that we need to do. And I guess I'll scaffold them out here in comments first. So we need to first get the global texture references for global sources, right? So that's those, that's the color buffer and the depth buffer that we've been talking about that are global, right? We need to get those first. We need to hook up the global sources, right? To the texture references. There we go. And then let's see. Then basically we need to traverse the entire list of all passes and verify that all syncs have sources bound. And then, let me think about this. Then figure out what is the last render target source output and link that to the global sync. Nice, my tablet just decided to reboot itself. That's pretty sweet. So we need to link that to the global sync, which we're calling the back buffer global sync, right? And that's ultimately what winds up getting presented, right? So we need to figure out that, and then basically it's just verifying that all of that exists, and then we initialize all the passes, regenerate our render targets for each one of those passes, and we should be good. So it's not a terrible amount of steps, but there we are. All right, so the first thing that we want to do is we want to get a global source count. So that's going to be a D-array length, and it's going to be graph global sources, right? And then we're going to loop through those. So U32 I equals 0. I is less than global source counts plus I. And then as we're sort of looping through this, I'm going to take a convenience pointer. So we'll say Rendergraph source. Rendergraph source. We'll call this source, I guess. And then this is going to be equal to the address of graph global sources sub I. And the first thing that we'll do is we'll say if source origin is equal to rendergraph source origin global, then we'll go ahead and take a look at it. Otherwise, we're going to ignore it, right? Which, come to think of it, I don't know that we actually need this flag. Because now that I'm actually thinking about it, it might be better for us to just link the source, like provide like a backlink to the pass that it's bound to, where that comes from. And then we can just check this by checking to see if that's a null pointer or not. So we might actually wind up refactoring that. But that's the original design I had in mind, so we're going to go with that for right now. And we'll recalibrate that if we need to. So the first thing that we're going to need to do with this is say U32 attachment count. And we're going to get that from the renderer. So render window attachment count get. That's going to tell us how many attachments we need for, basically how many frames we have, right? So for triple buffering, that'll be 3. If we're double buffering, it'll be 2. And then we'll say source textures, source textures equals, we're going to, James Harries, thank you so much for the follow. I appreciate it. We're going to k-allocate this. It's going to be size of texture pointer times attachment count. And we're going to tag that as an array. I think that's probably the best way to do it. Yeah, that makes sense. Okay, so once we have that, then we actually need to loop through the attachments themselves. So we're going to say for U32, we'll call this J equals 0. J is less than, whoops, I spelled source wrong up here. Just noticed that. Which means this is wrong too. No wonder my IntelliSense was broken. I was wondering about that. Okay, I think that's fixed. Okay, so j should be less than attachment count. Plus plus j. Right. And then here we'll look at if the source type, is equal to Rendergraph source type render target color, then we're going to go ahead and set source textures sub I equal to render window attachment get index I. And you'll note that this is very similar to what we did down here. The difference is here we're setting up attachments versus here we're taking direct texture references, right? So we have that, else if source type equals rendergraph source type render target depth stencil. Then we'll say source textures sub I equals render depth attachment get sub I, right? And I suppose we could handle an else here. Unsupported source type, and we'll just put the source type there and return false, right? So I guess we might as well catch that. All right, so that is getting the global texture references and hooking up the global sources to texture references. So actually we can just remove that. So next we need to traverse the entire list of all passes and verify that all sinks have sources bound. And then figure out what is the last render target whose source output figure out what is the last render target source output and link that to the global. Yeah, okay. So we want to link that to the global sink, right? So to do that, we are basically going to first check that the back buffer, what we're going to call the back buffer pass, right? We're going to start at the first user and then just sort of transfer down from that way, right? So we need to make sure that something is hooked up to that global source first. So I'm going to say Rendergraph pass back buffer first user, and that's going to be equal to like a null pointer, right? We're going to go ahead and get u32 pass counts equals the array length graph passes. Loop through that, u32 I equals 0, I is less than pass count plus plus I. Right. Then we'll loop through all of the sinks on that pass, and then for each one of those, check the source, right? So we'll say u32 sync count equals darray length. That's going to be graph passes sub I sinks. Then we're going to loop through those. So u32 j equals 0. J is less than sync count plus plus j. And in here we'll say rendergraph source. Render graph source. Guess we'll just call this source. And we're basically going to say graph passes sub I, and then sinks sub j bound source, right? So we're going to just examine that, right? We're going to take a convenience pointer so we don't have to type that over and over again, right? First, we're going to say if source right? And then within that, we're going to say if source, origin is equal to render source origin global, and source type is equal to source type color. Yep. So if both of those things are true, then we found it, right? So back buffer first user is going to be the graph passes sub I, and then we can break. And then here down below, as we've done in some other places, we just need to verify that we actually found one. So if not back buffer first user, then we can do k error, and we can say render graph configuration. I guess we'll call it error. No reference to global back buffer source exists, right? And that's pretty specific as to what the actual problem is, right? So we'll return false on that. And that's our first bit of error checking, right? We need to make sure that something is actually referencing that source. Let's see. I was tired to mess with it right now, but I feel like I need to look more into it when I do not fall asleep. I mean, I'm writing everything wrong again. Oh no. Yeah, I understand. When your mind gets tired, typing kind of goes out the window, which is probably why I can't type tonight. Okay. So actually, technically speaking, so this actually is just verify that something is linked up to the global color source, right? We don't necessarily have to worry about that with the depth buffer, because we can have an entire rendering pipeline that doesn't use the depth buffer, and that's valid. But something has to write to the color buffer, right? All right, so now we're ready to actually traverse this list. And so I think probably we're just going to do pass count again. So I'm actually just going to paste this. Right, and we're just going to iterate the passes once again. And we're basically just going to kind of go down the list and figure out which one's last, right, for the color attachment. So I think we have about a minute until ads. So I'll see how far I can get with this. So we have, let's just do Rendergraph pass. We'll call this pass equals the address of graph passes sub I. And then look for a what we're going to call a back buffer source for this pass, if there is one, right? Because not every pass is necessarily going to reference that. All right, we're going to break for ads for a second. We've got about 30 seconds left on ends. All right, and we're back. So first off, a great toaster. Thank you so much for the follow. I appreciate that. Maria Keating. Hi, friends. I've tried to compile the project on Linux, and I'm getting validation error about invalid VK descriptor set object before segfaulting. Any idea what's happening? I'm running a Plasma Wayland session, if that's relevant. There's a million things that could be. Did you get anything else in the logs before that? That's like maybe not specific to the descriptor set. Like, did your instance stand up correctly? Or was there some other sort of error that kind of came before that, where this is just sort of fallout from that? Because there's a bunch of different things it could be. Also, if you're running on Wayland, technically this would need to run through Xwayland, but it sounds like if you're getting to the point of descriptor sets, it sounds like you have a Vulkan implementation. Yeah, it's hard to say. It's hard to say without, being able to debug it, I would say. A window does show and you see some GUI stuff. And you're pulling from main, right? Because I think the main branch should work. I don't think I've pushed anything to that should break it. Did a straight clone from GitHub. Okay. And your drivers are up to date and all that? By the way, you're not going to be able to drop a link here in the chat, so you'll want to drop it on the Discord server and the Kohi channel. So there's a link to the Discord server in the chat, and you'll want to hop on there to drop it, because my bot's just going to block links. All right. So we were sort of looping through our individual passes here, and then we were going to look for a back buffer. Right, so what we're going to do here is we're going to say u32 source count equals darray length. This is going to be pass sources. And then for u32, we'll call this j equals 0. J is less than source count plus j. And then we basically just need to take, well, I guess let's take let's take a convenience pointer. Couldn't think of the word I wanted. Oops, not pass, source. That's going to be equal to the address of pass sources sub j. And then we'll examine the type and origin of that. So if source type is equal to Rendergraph source, let's see, we want render target color. And then if source origin equals Rendergraph source origin other. So basically this means other is a reference to the source output of another pass, right? So we need to search all other passes syncs to see if any have this source as a bound source, right? And this is sort of how we traverse down the tree, right? So what we'll do here is we'll say for u32k equals 0, k is less than pass count. We're essentially going to iterate passes again, right? So in this case, we'll do Rendergraph pass. And in this case, we're going to call this ref check pass. And we're going to set that to the address of graph passes k, right? And we'll go ahead and get another, let's see, I don't think we've gotten a sync count. So we'll say u32 sync count equals darray length. And that's going to be ref check pass syncs. And then we are going to iterate our syncs for that. So we're going to say for u32, we'll call it s equals 0. S is less than sync count plus s. And here we'll say if ref check pass syncs sub s bound source equals source. Then we'll say found equals true, and we will break. Which actually, found, I don't think we've actually put in here. We need that here, outside this loop. So b8 found equals false. Okay? Why is it bleating about incompatible pointer types? It is up here too. Rendergraph pass, graph passes. Rendergraph pass pointer. Am I missing something here? That should be valid. These types are the same. Why is it complaining? You know what? I'm going to ignore that until I build. Okay. So now that we're there, we basically need to do a check to see if we found what we were looking for, right? So if we loop through all of the syncs and we didn't find what we were looking for, then we should be at the end of the line, right? So if not found, then that means end of the line. This source should be hooked into the back buffer global sync. Now, this might not necessarily always be true when we have more complicated resource and linking dependency detection. We're probably going to have to refactor this. But for right now, this should be sufficient for what we need. So we're going to say graph back buffer global sync bound source equals source. And then we're going to set the pass presents why is that? Presents after. I don't know why my IntelliSense is failing on that. No member presents after instruct Rendergraph pass. There is, though. Is there not? Oh, there is. I thought I included that. I could have swore I included that. So one thing that we need to know about each render pass is whether or not the results from this pass are going to be used for presentation. And I could have swore that I put that in here, but apparently I did not. So the default for that is going to be false for every render pass except for the one whose source is bound this way to the global sync. So there's that. We need to break that. And then outside the check for the type, we also need to perform another check. So we need to make sure that if graph the buffer global sync bound source, right, if that exists, then we're done. And then one more level out from there, which is going to be here. We're going to perform the same check again. Bound source, break. Right, and that takes care of these for loops up here to break them out once we've actually have a bound source. All right, so at that point, we've looped through everything. We've hooked up the target output. The next thing that we need to do is double check and make sure that we actually bound something to that global source. So if not graph back buffer global sync bound source, at this point we're going to throw an error and say unable to link back buffer global sync to a source because no source was found. Turn false. Right, so that's just a little verification there to make sure that we actually have something hooked up to that, because something has to be hooked up to that. We always have to have at least one render pass, and that render pass has to at least hook up to this bound source. So the next thing is once all linking is complete, initialize each pass. Right, so we're going to need to loop through our passes again. So for u32 I equals 0, I is less than pass count plus I. Right. And in this case, we're going to say if the result of graph dot passes sub I initialize, and we're going to pass to that the graph passes sub I. So if the result of that is a failure, then we're going to bleat about it, basically. So error initializing pass check logs for more info, I guess. And at this point, we're going to return false because of that. If that succeeds, then we are also going to regenerate the render targets. So we also generate render targets. Right? So if for some reason that fails, so we'll call regenerate render targets. We want the graph, and then we want the graph passes sub I. So if for some reason that fails, let's bleat about it and be specific. Failed to regenerate render, render targets. And then return false. And if we get all the way past all of this, then we return true. And that means that everything is hooked up and we're ready to go. Which is pretty long-winded. All right. Let me catch up with chat here. So let's see. Where in Discord should I paste? I would put the link to that. There's a Kohi channel in there, the Kohi series channel. I would say go ahead and put it there. And I'll see if I can quickly come up with what it is just by reading through the logs. Agathon813, welcome, first time chat. Appreciate that. You seem nice, and I like that you explain as you code, unlike the last C streamer I watched who only seemed to attack his chat commenters before asking questions. So the whole point of my stream here and the YouTube video or the YouTube series that goes along with our channel, whatever you want to call it, is it's supposed to be an educational resource, right? So the reason I'm writing all this stuff from scratch is as a resource for people to learn how to do it. And it's not the only way to do it. It's not necessarily even always going to be the right way to do it. There's always going to be pros and cons, trade-offs for everything. It's a way to do it, right? So I by no means consider myself an expert on any of this stuff, and I certainly do not, talk down to people and things like that. I welcome conversation. I welcome the asking of questions, and I try to solve them to the best of my ability. Sometimes I can, sometimes I can't. And I just try to be real with people, right? Because I think the industry as a whole could use a little bit more openness and a little bit more kindness and a little bit more sharing of information instead of gatekeeping, right? So I'm trying in my own sort of way to do that. So yes, the YouTube is there. So that's a link to that as well. This actually started as a YouTube tutorial series and sort of morphed into being done online. So that's kind of how we wound up where we are. I agree the industry needs more of this. Good for you. Cool. I'm glad you appreciate it. Hopefully, the way I look at it is if somebody is inspired by this to kind of go off and do their own thing and learn more, then I consider that a success, right? So even if one person were to tell me that they were inspired by it to go and do their own thing and they went off and did that, then I consider that a success, right? Cool. Okay, Maria, I see your paste bin here. I'm going to take just a quick 30-second look at it just to see if there's anything else in here that I can quickly pick up on, and then I just have to finish up this code real quick. I may have to troubleshoot it with you offline. Let's see. Color attachment load operation is, yeah, there's some warnings in here. Color attachment load operation is set to load, but is also set to clear. This combination is invalid. So something tells me that your setup potentially with your render passes might be wrong. You might have something wrong in there, or something maybe that isn't compatible with your hardware setup. Let's see, you're on a Radeon 6700, which I have not had I don't have any Radeon cards. I'm going to have to buy one eventually, I think, so that I can test on it. So maybe there's something with your hardware that is not supported or something that Vulkan doesn't like. I'm not sure. Let's see. You know what? Let me pull this over here so the rest of the stream can see it, actually. So we're getting some performance about outputs not consumed. I I think that's literally just the, wait a minute though. Location 1, 2, 3, and 4. That seems wrong. None of these are supported. So your shaders are just not like loading correctly at all for some reason. Which is going to be the reason behind this descriptor set stuff, because I don't think like if this bit is failing here, then something else is going on. Okay. You're on the Mesa drivers. That may be part of the problem. In fact, I'd almost guarantee that's a problem. So the Mesa drivers are known in some cases to not always work with Vulkan. So I would say if you can use the proprietary drivers instead of the Mesa drivers, maybe do that. That would be the thing that I would try first and foremost. I hope that helps. Let me know if that does. I have a feeling that's probably part of it. Okay, let's see. LSR, I just started watching your first couple of Kohi videos on YouTube today. Okay, cool. Well, welcome. It's great to have you on board. I've worked as a dev for 2 years now in e-commerce and want to start learning C++. That's why I was finding a stream like this one. So this one does assume a little bit of knowledge about C and C++. I use strictly C here, and I would recommend if you're looking to learn C and C++, I would start with C, absolutely, because it's a simpler language. And then once you have a solid understanding of C, C++ will come a lot easier to you. Make sure that you wrap your head around how pointers work and all that stuff. I do have some really basic videos on C on my channel. It's a series that I've actually need to really get back to expanding because it only really covers the basics, but there might be some stuff on there that could help you. You're unwilling to switch due to performance loss in games. Performance loss, really? The proprietary drivers are worse for you? That's interesting. You know what? I will, maybe I'll set up a virtual machine and see if I can't get again though, I'm not using an AMD card, so I'm not sure that I'll get it to work, but maybe I'll try playing around with the Mesa drivers a little bit. I haven't actually had a chance to test on it at all, so I have no idea if it works. I just remember people from a couple years ago saying the Mesa drivers didn't always work so well with Vulkan. So I'm not sure if that's it. Yeah, I'm not sure what to tell you there, unfortunately. That's one of the drawbacks of Linux, unfortunately, is there's so many different sources of drivers, right? Do you have like a Windows setup that you can use instead? That maybe you can try deving on, as much as that kind of sucks. Or like maybe maybe you could dual boot or set up a VM or something. All right, let's get this execute frame knocked out because it's really, really short. So literally all we have to do is I was going to copy pasta, but it's short. I'll just write it. So passes, for now, will be executed in the order they are added, right? So basically we're going to have u32 pass count equals the array length. We're going to go with graph passes for u32 I equals 0. I is less than pass count plus I. And then we'll just check the result of that. We'll just do a negative check on it. So we'll say if graph passes sub I execute. And to that, we'll have to pass along graph passes sub I and p frame data. Right, so if that fails, what we're going to do is k error, and we'll just say error executing pass, check logs for additional details, and return false. Right, and that's literally all there is to it. Right, the execute just executes them in the order that they were added. Now, eventually, we're going to have some advanced sort of dependency checking between the sources and the sinks, and we won't necessarily have to rely on this order because we're also going to eventually multi-thread this. And so we want the ability to potentially execute a whole bunch of these things at the same time. So in order to do that, we're going to need eventually some more advanced processing of dependencies. But for right now, this basic version, we're just going to process them in the order that they were added. Okay. All right. That is pretty much the render graph, right? So the next thing that we're going to have to do is we're going to have to actually implement the individual render passes, which is actually going to be the bulk of the work, right? So that is the next step. Let me see. Maria Keating, I could put a GPU in for a virtual machine with a pass-through, but I just want to play around with it. I'm not super invested in it actually running. I was more thinking there was a bug I could help solve. I'm heading out. Good luck with the rest of the stream. I appreciate it. I will look into that, though. I appreciate the paste bin. And I really need to go ahead and get my hands on an AMD card, right? Because I am interested as to why this is doing what it's doing. But unfortunately, without the ability to like step through it, there's not really a whole heck of a lot that I'm going to be able to do. I do have a little bit of information here, but it looks like it's just not creating the resources correctly. The thing that's strange to me is I would imagine there's lots of other games that run on that setup, so I'm wondering what's different from mine as opposed to that. But I can't be sure, obviously, without being able to step through that. So let me see. So we're applying the globals. Huh. Okay. So yeah, I'll take that information that that you gave me, and if I need anything else on that, is it cool if I ping you on Discord? If you're still here. All right. Incidentally, I should point out also, so like if you guys wind up actually finding like a bug or something like that, another way that we can handle it, and maybe the preferred way. Oh, you know what? Ads. Cool. All right, so we're back. So the thing I was going to bring up is I dropped a link to the Kohi engine website in chat. It's just kohiengine.com. And we have sort of all sorts of information here about this project. So link to YouTube, Twitch, all that stuff. We also have a link to the GitHub. So everything here is open source. So all of that is available to you guys as we do this stuff here on stream. I try to commit that and push it up, even if it's to a feature branch like what we're working on now. So all of that is available here. We do have a wiki that I'm working on, which also has a roadmap, right? So I probably need to update this because there's a couple of things in here that I've done. But it has basically all the to-do items in here, just in general, engine items, as well as render and UI-specific stuff. And then the other thing I wanted to point out is we do have the ability to log bugs against this. So if you guys actually have... if you guys have like a bug that you run into, similar to like what Maria was running into there, feel free to open an issue here and put in your logs and any information you have on reproducing the issue, and we can go ahead and address it here. I have a few things in here. I try to keep an eye on this. Like here's another one for AMD cards, right? Like there's some of them that I'm not going to be able to get to because I don't have an AMD card. But yeah, I mean, at least this way I've got all this stuff in one place, and I can sort of go through and fix that, right? Like this one, I think I'm pretty sure I fixed this one already, for example, in this one. But anyways, yeah, kohiengine.com. It's got links to all that stuff. It's got links to, Patreon and that kind of stuff. If you want to support me that way, no pressure. If you want to, cool. If you don't want to, that's totally fine too. So that is pretty much that. I think as far as tonight goes, that's probably where I'm going to wrap it up. This is a pretty good stopping point. So the next thing that we're going to do on the next stream is we're going to go through these views. Actually, not the pick one. That's a bad example. And we're going to pick out all of this sort of material information and resource information and the rendering bits out of these. And we're going to move those over to the individual render passes. And then as far as the packet generation, where we generate all the data that we're going to need for the actual render pass to be able to handle, we're going to move that out to and probably Jobify it within the testbed application so that we can potentially multi-thread it and handle multiple of these things at once, right? So we're gonna see where we wind up on that on the next stream. Let's see. Ended up installing Manjaro with i3 and the RAM usage is crazy low. Yeah, I could believe that. I totally believe that. It's like a bare bones Arch install is pretty low. Of course, I've got all kinds of crap installed in this, so my memory usage is quite a bit probably, especially since I've got like Chrome instances running and stuff like that. It's probably not that great, but I have 64 gigs, so I'm not worried about it. All right, so like I said, I think that's probably where I'm going to wrap up. I really appreciate you guys being here and following along. Let me see who is online that I can raid real quick. Let me see. I'm actually just going to go to... Let's see who's online right now. Let's see. We have Stragger. He's always got some interesting stuff. Actually, for those of you who are looking at learning C and C++, he's a really good resource on that because his whole stream is actually dedicated literally to code help and advice. right? So he's actually, you know what? I'm going to rate him actually. That's who I'm going to go with for tonight. So his whole stream is basically dedicated to helping people learn stuff or answering questions about programming in general. He's not just limited to C and C++. I think he does a lot of JavaScript stuff too, as well as some other languages. I'm not 100% sure of all the languages he does, but he does a lot of work in C and C++. So that's who we're going to go ahead and raid tonight. Thank you guys so much for joining me here, and I will see you guys on the next stream. Peace out.